Welcome. My name is Victor Chin from Firebrand Training. Today, we will be talking about infrastructure as service, VM operations. For many years, organization has been running virtual machines to increase the density and utilization of their on-premise hardware. Tailwind Toy just began the journey migrating their machines into the Azure cloud environment. Now, in this transition, engineers at times get the wrong idea about what does it mean by running a virtual machine in the cloud. Now, a common misconception is that once we bring this into the cloud, somehow our software will automatically be updated. Somehow our data gets backed up magically. Now, in a cloud operation, we have the vendor, in this case, Microsoft Azure. Microsoft's commitment is to ensure that physical assets are up to date, data center operations are reliable and highly available, and the cloud infrastructure is scaled to accommodate all sorts of demand from the customer. Now, a joint responsibility is that Microsoft provides the tools that allows the customers to perform their own backups using their own schedule, following their own routine and needs. The workload that runs in Azure needs to be updated, needs to be inventoried, needs to be accessed securely. Now, those are the responsibility of the customer. So in today's session, we're going to look into Tailwind's most immediate challenge, bringing the virtual machines into the cloud. First, how do we connect to it? Keeping a virtual machine directly on the internet and leaving the remote desktop protocol port open, 3389, is a pretty bad practice. Now we're going to look at two options. Option number one, an Azure Bastion server. We'll see a demo of how to keep the machine in a private VNet and using nothing but a portal to connect to it. We will also look at just-in-time access. Virtual machine needs to be backed up. Some virtual machines can just snapshot all the virtual hard disks and back them up. Now, perhaps you're running other type of workload. In this session, we'll look at how to back up Azure SQL. Besides the operating system, there are many software that runs in these VMs that needs to be updated regularly. Now we'll look at the software update and inventory feature that's built into the Azure cloud. Now, to ensure that we don't have a configuration surprise, Azure gives us the ability to monitor software changes, installation, uninstall, registry changes, daemon startup, shutdown, Windows background service status. Now we will also look at how to collect all these information and be able to see them centrally. Before we get started with the day's agenda, we're going to have to first create a virtual machine to be used for the rest of the talk. To create this virtual machine, we'll be using Azure Cloud Shell. The Cloud Shell can be started from the portal using the icon that you see on the upper right hand side of your Azure portal. You can run this portal with a Bash environment or a PowerShell environment. Both of these runs on a Linux shell. This shell will mount an Azure file share so that all your command histories or your profiles, all your key that's generated in this environment will be kept throughout the session. Just make sure you don't delete the storage account or the file share. Now the AZ CLI that you see here, AZ500-VM create, will create a Windows virtual machine using the Windows 2019 data center image in the resource group TTVMs. Now the password is defined right above. Now it takes about 5 minutes or so to get the virtual machine ready. Now our virtual machine will run in an isolated, dedicated subnet. Now, let's say the company decided to deploy this virtual machine in the VNet. Giving these machines a public IP and have port 3389, the RDP port, open to the internet, it's a pretty obvious attacking surface. People will be port scanning these machines and will be trying all kinds of RDP or SSH access to the machines. Worst case, people get into machines. Best case, well, people attempt to make connections. Okay. So one novel approach is by providing a Bastion server. In the next slide, we'll see how we can configure Bastion server so that machines answers only on the private VNet through a Bastion server. All right, so at the moment, looking at the virtual network, we can see there is a virtual machine that makes use of a internal NIC listening on private IP 10.0.0.4. In order to support the Bastion server, we need to create a dedicated subnet. So 10.0.1.0 subnet is going to be used to deploy the Bastion host. All right, so the subnet is now ready. All right, with this dedicated subnet in place, we're going to go ahead and create a Bastion resource. Now, naturally, the Bastion resource must reside on the same region, in the same region as the virtual network. Now, ensure we select the dedicated subnet that we created earlier for the Azure Bastion network. All right. Now, once this resource is created, we can now head over to the virtual machine. Now, notice our virtual machine still does not have a public IP. A single Bastion server that we deploy will be able to provide access to all the virtual machines that reside in the same VNet. Okay. Now, as you can see, there is no public IP assigned to this virtual machine. All right, so we're going to go to Overview. Now, when we make a connection, we now have the option of using a Bastion server. All right, so this is a username that we use to create a VM with. All right, and we will now be looking at a browser-based RDP session. Now, if this were a Linux machines, we'll be looking at the Bash environment. All right. Now, just to confirm that, yeah, this is connecting to the virtual machines. All right, so just quickly recap. When we deploy the Bastion subnet Keep in mind there can be no other resources residing in this subnet. It has to be used exclusively for the Bastion host. The administrators will log on to Azure Portal and use the Azure Portal to connect to the Bastion server. So that means none of these machines will be accessible over the internet at all. So NSGs will allow the Bastion network connections to the necessary remote desktop port and SSH port. So this is one way to provide machines that does provide access, RDP access, to machines that does not need a public IP. For machines that needs to be accessible over the internet or managed over the internet, we have another option called just-in-time VM access. Now this technology is built on having a standard license in Azure Security Center. Now when the machine is enrolled into the standard monitoring package in the Azure Security Center, we can now create a just-in-time VM access. Now in a subsequent demo we will see how we could configure machine to require just-in-time VM access. Alright, so we're going to start from the Azure Security Center. Now as long as the machine is managed by the standard tier of the Azure Security Center, we can turn it on and enable just-in-time access for this virtual machine. Now these are the ports and also the default time range to allow access. So we're going to delete a few of these. This is a Windows machine. We don't need these other ports. The only ports we want just-in-time access would be the RDP ports. Alright, so here we're going to configure the port. Here I can specify the IP address I want to allow access to the RDP based on the request at the time. Okay, so per request means if I'm making a request on this machine, then my exit public IP will be on the whitelist for X amount of time. So the technology behind the just-in-time VM access is a Microsoft Azure managed network security group rule. All right. I can also, if I know the IP network segment ahead of time, I can also make that using a CIDR notation. All right. And I can also limit the maximum amount of time where the port will be allowed. All right. So let me save this configuration. All right. So now anyone who wants access to this virtual machine must request for access. Now toggle it on for the next 10 hours and my client IP address will be allowed. Now if we go review the NSG group, we will see a just-in-time added rules to allow the access. So now we can try to connect using the RDP profile to make a connection to the machine. Now we use this when the machine absolutely need to be managed via a public IP, but at the same time we don't want the port to be open all the time. Okay, so upon activation we will keep the port available. Alright, so we're into the machines now. Now that our machine is operational in the Azure VNet and we have secure access to the machine, we're going to shift our attention to the workload that's hosted on the machine. Now, in order to make sure that we build some reliability into the workload, backup/restore is some of the most common things that everybody need. So in the next section, we'll be looking at how to back up VM workloads. We're going to look at two kinds of VMs: a basic virtual machine and a virtual machine that runs a SQL server, SQL database in an infrastructure service manner. Now the Azure Service Code Recovery Service Vault serves as the basis that performs backup of virtual machines and infrastructure SQL. Alright, so we need to create a recovery service vault. Now it's always a good idea to keep the vault in the same region when you are going to be using it for virtual machine backup. So there's no reason to have recovery service vault live somewhere else. Okay. So once we create a recovery service vault, we typically begin by configuring a backup. Okay. Now in this wizard we'll be asked where's our workload running on. Could be Azure, could be on-prem. Now in this section we're going to focus on backing up virtual machines. Alright, so our very next stop is to configure a backup policy. Now this policy controls the frequency, the retention, and also the instant restore capability that lets you use the snapshot to perform the restore. So it's much faster than full machine restore. The amount of retention for these backups. Alright, so we'll be using default policy, or we can also create a new one. Okay, this is the VM policy at a certain time. Alright, so give our policy a name. Not only we can specify how frequently we want to back up. Now keep in mind you can only back up as frequently as a daily schedule. Okay, you cannot back up a machine more frequently than every 24 hours. And also you cannot have a single machine be backed up by more than one vault. Alright. Now we can specify long-term retentions for the weekly backup as well as the monthly backup, or even yearly backup. Now there's going to be 99 backup points. Okay, and we can select the virtual machines that we want to back up, and that schedules all the machines to be backed up on a daily basis. Now if we have a SQL Server workload in a virtual machine, the tool is also capable of discovering what database is running on that infrastructure service. Now this VM that we have here has a few databases. All right, let's take a look. All right. So there's a SQL Express instance currently running on this VM. So we're going to select that standalone instance. And the Tailwind Traders is the database we want. Now any additional database can also be included. Alright, so this will schedule the backup. Alright, off it goes. Alright, now back to our vault. We're going to take a look at the item that has been backed up. So I'm going to scroll down, go to replicate items. Oh, sorry, backup items. Apologize. Now in the backup item, now we can see the SQL database that we're backing up as well as the virtual machine. So these are all the VMs that we're currently backing up. And we're going to force a backup so we don't have to wait until the schedule occurs and when we can delete these backups. Alright, backing this one up as well. Alright, now my database has been backed up. I'm going to RDP into this SQL database. Now you can see I have a database that was backed up through the SQL backup. Alright, so I'm going to try to delete one of these tables within the database to make sure that my restore can actually bring the table back. Alright, so I'm going to go ahead and drop this table. Alright, so I'm going to navigate to my SQL in Azure, the Tailwind Trader database. It takes a moment for the Restore DB button to show up. Okay, so I'm going to click just that. Alright, so I can choose to restore this to an alternate location, so to a different database. Okay, or I can override existing database. Alright, So this is the restore point of my full backup. Now this is the log name and the target location where the restoration will restore the new database to. All right. Now switching back to the RDP session, I'm going to do a quick refresh. I can see the new restored database, and there's where I can see the table is now returned from the restore, from the backup. Now we're going to try to look at the virtual machine that we have backed up. Okay, now to restore a virtual machine, we have a few choices. Okay, we can select the machines we want to restore, and we can restore the entire VM. We can do a file level recovery, in which case Azure give us a script to mount the hard disk as of a specific timestamp, so we can copy the files we want. Alright, so we can also restore the VM to a new storage disk. Alright, so I'm going to do a restore VM. Alright, so this will present me with a snapshot time to restore from, and I'm going to create a new virtual machine as of the time where the backup was taken. Alright, so I supply the restored machine name along with the storage account to keep the virtual hard disk. Alright, so the request has been submitted. Let's go ahead and take a look at the activity logs to make sure these request has been registered. Okay, so you can see our restore request has been accepted and started. Alright. Alright, looks like it's completed successfully. Now we can go back to our resource group and look at our virtual machines. There's our Ubuntu restored from the backup. Alright, so let's recap. When we back up a virtual machine, we configure our backup policies. Okay, and we register the machines up to 4 terabytes per disk can be backed up in Azure Backup Vault or Recovery Service Vault Backup Service. Volume Shadow Copy Service will snapshot these disks and send it to the Recovery Service Vault, okay, for instant recovery. Alright, now everything that's stored in the Recovery Service Vault, we have storage service encryption. Okay, we also have backup encryption key with a key encryption key stored in a key vault to make sure no one can just pull the backup and restore the virtual machine on their own and compromise the contents of your virtual machine. Alright, so we can accommodate up to 1,000 VMs. In a Linux, okay, you are given a pre-backup script. Okay, the virtual machine will then be then snapshot the hard disks. Okay, perform the snapshot copy. It happens almost instantly, and the postscript that runs after the snapshot is taken. Now this will give you an application consistent VM backup because all the disks will be frozen on the same exact timestamp. Okay. All right. So we have a virtual machine that's backed up. We can recover individual files, the complete disk, restore to a separate VM, or an in-place restore that overrides an existing VM. So these are all the choices once you have backed up the virtual machines. Now, we just saw earlier we can discover the database that runs, that's attached to a SQL instance within the virtual machines. We can back up 50 databases at once, while each database being 2 terabytes in size. Okay. Now we can also enable the auto protection, so any future database that's created on this hosted SQL instance in a VM will automatically be included in the backup. Now it depends on the mode of your database operation. Now if we have transaction log being recorded as part of our backup, then we will have point in time recovery to the specific seconds or the transaction that we want to recover to, point in time recovery. Now if we are taking full and differential backup only without the transaction logs, then we can restore to the last full or the last full plus the differential that we want to restore to. But these typically will not give you point in time recovery. This will give you the restore at the time the differential backup is taken. All right. Now you can only restore the database to an instance of SQL Server in the same region. Okay, so keep that in mind. Okay, you cannot do cross-region restore through Recovery Service Vault. All right. So keep in mind that the destination server that you want to restore the database to has to be registered to the same vault as the source we're backing it up. Naturally, you can also use the same server. Now, if your database uses transparent data encryption to encrypt the data files, now make sure those encryption certificates, including the private key, is transported to the server that you want to restore your TTE database, because without that private key certificate, your SQL service will not be able to mount that data file once they're restored. Okay. Now with our VM running in the Azure environment, the cloud allows us to provision the resource just in time. When we need bigger box, we can get them quickly. Okay. When we don't need a very powerful boxes, we can quickly scale them down. Now I'm navigating to this virtual machine and going to the sizes. There's a set of filters that I can use to control the size that's displayed on this list. Okay. Now these different machines supports different number of CPUs, different network capabilities, okay, different number of disk that can be attached, the number of NIC. Okay. So all in all, these virtual machine represents a compute resource. So our emphasis is its ability to process workload. All right. So selecting the sizes and click on the desired size and select resize, and that's the end of it. Now anytime you're resizing the machines, remember your kernel has to restart to address these additional hardware. So this will always cause the machine to reboot. So keep in mind, as convenient as resize is, it will always cause your machine to be restarted. All right, so that is done. Now once we have a bunch of virtual machine running in the Azure platform, our next challenge is to make sure that vulnerability gets patched, software gets properly updated. Now in Windows, we have traditionally relied on WSUS server to approve patches, updates, okay, various KB software patches to be deployed on Windows operating system. On Linux, we have various package repos that can be used to update dependencies and packages. Now in Azure environment, we rely on the update management that's provided by an automation account. So here we'll take a look at how we can configure the machines to be managed by the update management feature. Now I would like this virtual machine to be managed by the update management service. So the first thing I'm going to do is go to this machine and enroll it to be managed by an automation account. So navigate down to update management. All right, so I can enable update management for this virtual machine. It will create a log analytic workspace as well as an automation account in this region to support this VM. Alright, so that is done. Now immediately it report back with some missing updates. Now I need to add a few more machines. So besides Windows, the update management can also monitor Linux packages. So I'm also going to enable VM, but this time I'm going to enable all the virtual machines in this subscription. Alright, so you can see that one on top has already been installed, so we'll continue to use that. And we don't need the machine that's just restored, so skip that. Alright, so these machines are now enabled for update management. Well, let's go ahead and schedule an update. So navigate to the update management node in the schedule updates. Now I can choose the exact classifications, the different types of updates I want to apply. Now if there is specific knowledge base that I want to skip, perhaps incompatibility and so on, I can exclude it here. Alright, whether I want to do a one-time patch or this is going to be a recurring weekly thing. Okay, I can choose a recurring schedule or just a one-time schedule. In the automation account, I can also create script assets to have them run before and after these updates are applied. The maintenance window controls the number of updates that can be installed. When the maintenance window closes, if there's any update in the midst of installing, you'll be allowed to finish. Okay, but once the maintenance window closes, no additional updates can be applied until the next scheduled window opens. Now, if the updates need to reboot, you can choose to reboot automatically, or you can have it not to reboot. I'm going to do the same for the Linux machines. Alright, so I'm going to go manage the other machines. Now you notice by trying to manage multiple machines, I am now looking at the automation account. This automation account is the service that supports these update managements. Alright, so I'm going to select my Linux box. Okay. Now these are the machines that I want to select. Alright, this time I'm going to set up a recurring schedule that happens Patch Tuesday. Sounds good. Alright, so select the times where every Tuesday these patches will be deployed. Alright, so now after some time, this update will be scheduled. Okay, I can look at the deployment schedule. So these are the two schedules I've made to weekly update the Linux and a one-time update of these window boxes. Alright, so once we configure the update management, Windows will scan every 12 hours to find out if there's any additional update that can be applied. Now on Linux, the default Linux will search for every 3 hours. Now all the Linux image that you provision from Azure VM Marketplace has a Microsoft Management Agent installed, so that makes the scan down to every 15 minutes. Now if you have your own WSUS server, you can point the Windows computer to your own WSUS where you can approve what update package to deploy. Okay, and same with Linux, you can have your own local repo of which you can then make available these Linux updates. Windows, Red Hat's RHEL Linux, okay, SUSE, Ubuntu, CentOS are the supporting operating systems running in Azure that can be serviced by the update management you just saw. All right. Now, once our data machine is operational, we would like to know when software is being deployed to the machines. Okay. We want to even be notified when there are certain configuration changes. Okay. So configuration management and inventory, as well as change tracking, can help us identify what has changed, registry, files, or software. Okay, so we are going to take a look at how to inventory and perform change tracking. Alright, so I have a virtual machine here. I would like to enroll this machine into change tracking as well as inventory. Now both of those relies on log analytic workspace. So I'm going to enable the inventory as well as enable change tracking. Alright, so this will take some time to enable. In the meanwhile, I'm going to go deploy the change tracking to a Windows machine as well. The previous one was a Linux box, a Ubuntu box. So here, I'm going to turn on update management, inventory, and change tracking. So it looks like I've already done this. Inventory, enable this. All right, and turn on change tracking. With the change tracking enabled, we are going to the virtual machine and we're going to try to install a piece of software to see if our change tracking and inventory picks up the new installation. So I want to make sure this virtual machine is also being monitored by the same automation account and log analytic workspace. Alright, so enable the inventory and momentarily be enabled. Alright, so I'm going to go into the virtual machine and use Chocolatey, which is the Microsoft's package installer. Okay, you can go to chocolatey.org and we can use this command line to install softwares, just like you could do that with RPM, apt-get in other platforms. Alright, so this installs Firefox. Okay, so it works well. Alright, so now we're going to navigate to change tracking and take a look and see if the software changes has been detected. Okay. So here the change tracking would have indicated the software was indeed installed. Okay. And was picked up at that time. Alright. Now with the machine enrolled into change tracking, in the change tracking section, I can now monitor the changes that takes place on the VM. Now in the edit settings on top, I can define the files that I'm interested in monitoring. Okay. Now in Linux, it's very common all the software configurations are stored in the etc folder. Okay. So this will automatically pick up anytime this conf file has been modified. So this is an out-of-box rule. We also have the choice to upload the modified file once the change has been detected. Okay, so now we can also track if this is a Windows workstation, a Windows file, a Windows registry. contents of the file that we want to keep track of changes, and background services. All right, so this is where we can customize what type of change we would like to track. Now it depends on the items that you're tracking the changes of. Now Windows registry, Windows file, and Linux file are monitored at different frequency. Okay, so these are the different frequency of which these event change type will be picked up and reported. All right, so the number of files and the number of registry we can monitor per virtual machines. Okay, so these are the frequencies. So it depends on the event. You may have to wait some time for these events to be picked up by the change tracking. Now to recap, this inventory and change tracking let you monitor when the service is stopped or when softwares are installed into the virtual machine, so you have a history of what has happened. You even have the ability to pick up files that has been modified, so you can see what has changed between the versions of the files. So software's installation, background services, Linux daemons, Windows registries, file changes can all be monitored through these solutions. Now for machines that's running outside of Azure, you can install through the Log Analytics Advanced section an Azure agent. Now to enroll machines outside of the Azure environment to be monitored by the change track and inventory, you will want to navigate to the Log Analytic workspace, head over to Advanced Settings. Now this is where you can download Windows Agent to run on on-prem or other cloud. So you can now deploy these agents onto Windows and Linux, and they will observe and report back the inventory information and also the tracked changes. Right. Now the various operating systems that supported, most of the common ones, the CentOS 6 and 7, Oracle Linux 6 and 7. Okay, these are pretty much same thing, all Red Hat variations. Okay. All right. Now, folks, there are going to be virtual machines that doesn't need to run all the time. So, virtual machine supports auto shutdown. So, if you have a virtual machine and you want to ensure that perhaps, 9 p.m. no more Minecraft. Okay. We can go to auto shutdown and schedule a time that it always turn off. All right. So in this session, we've covered how to access virtual machines that is deployed into a private VNet. Okay. We can use Bastion Server to not having each virtual machine assign its own public IP. Okay. We can also use just-in-time VM access. Now that requires a standard tier Azure Security Center coverage on the virtual machines. We then look at how to protect the data stored in a virtual machine, as well as a SQL installation within a virtual machine environment. Okay. We're able to back up a database. We're able to restore the database in place or restore to a new database. For virtual machine backup, we can do whole drive restore, whole machine restore. We can do file level restore. Okay, so these are different ways we can recover from user errors or machine outage. We've also looked at the automation accounts coupled with log analytics provide the ability to deploy softwares, updates. perform change tracking and inventory softwares that runs on our cloud VMs. Okay. Now, many of these services can also be extended to virtual machine running on-prem. So if your environment hasn't yet deployed a SCOM server, or you're planning on doing pure cloud transition or transition purely to the cloud, these are good management platform to consider. Thank you for your time. We will now take a 5-minute break before our next session.